Okay, good morning, boys and girls. Today you're going to watch a video lesson on scatter plots. Remember, you need to take notes on a separate sheet of paper that you can turn in. Below, you can see what the goal is, so go ahead and write that in your goal sheet. The first thing we're going to talk about today is being able to identify correlation. And if you recall from last year, there's two different types of correlation. We have positive correlation and we have negative correlation. A positive correlation is a lot like positive slope. It's increasing. A negative correlation is like negative slope. It's decreasing. One thing we're going to add this year is whether it's a strong correlation, it looks a lot like a line, or it's weak. It's not quite a line. And remember, there's always the possibility that there is no correlation. So let's look at this first example here, calories burned during exercise. That's going to be a positive correlation. And do you think that it's weak or strong? Well, it doesn't make a very good line, so we're going to call that a weak correlation. What about letter B? This one's going down, so that means it's a negative correlation. But you notice how it makes a much tighter grouping? It looks more like a line. So we would call that strong. How about the library fines problem? What kind of correlation do you see there? That would be no correlation. All right, what about the dealership revenue? That would be a positive correlation. And is it weak or strong? Definitely strong. All right, so you guys remember that from last year. Now, when we're talking about correlation, we need to keep in mind that there's this thing called causation, okay? Correlation you already heard about. That's the positive, negative, or no correlation. It's the general pattern of the data. Causation means that one variable causes or produces a change in the other variable. So, for example, if we have the years that you own a car and the price, the older the car is, the cheaper the car is. Okay? The age causes the price to decrease. So that would be causation. Okay? Correlation can be observed between any two random variables. For example, let me show you a good one. I got one right here for you. So in this example, we've got the water consumed in a certain year in gallons, and the tuition at some school. Those are two variables, and you see if we graph them, we have a very strong positive correlation. But do you think that the gallons of water consumed causes the tuition to increase? No, absolutely not. That is not causation. It is correlation. They have something related to each other, but they don't actually cause one another to happen. Okay? So going back to my other example, when we're talking about a car, the older it is, causes the cost to decrease. That is causation. When the two variables have nothing to do with each other, that's just correlation. There's no causation. So it's beneficial to keep that in mind when you're looking at scatter plots. All right. Do you guys remember how to make a scatter plot? The first thing you have to do is identify your x and your y variables. So here we've got this problem about roller coasters. Okay, the table shows the largest vertical drops in roller coasters in the United States and the number of years after 1988 that they were opened. So the independent variable is going to be the year, that's our x, and the dependent variable is going to be the vertical drop, that's our y. Okay, so the vertical drop depends on the year that it was made. So we're looking to see if there's a relationship in the data, and then we're going to make a prediction. All right, so when we graph this, the x-axis looks like we go 1, 3, 5, 8, 12, 12, 12, 13, 15. So maybe going by twos. All right, so I've got my x-axis labeled. Now on the y-axis, we're going by vertical drop in feet. I see that my biggest one is 400. My smallest one is 150. So maybe go by 50s. I'm going to start at the top to make sure I have enough space. 400. All right, and since I didn't get all the way to 0, what do I need to show on my axis? A little lightning bolt, right? That's an ugly lightning bolt. All right, so we've got our axes labeled. Now I just need to put my points on my graph. So this is an x comma y, 1 comma 150. So that's going to go about there, más o menos. 3, 155. All right, and keep plotting all those points. All right, so you can see by all those points that we definitely have a positive correlation, meaning that the years since 1998, as they increase, the vertical drop on roller coasters increases. So there's definitely a relationship in the data, and the relationship would be a strong, positive correlation. And then it asks us to predict a vertical drop in the roller coaster built 30 years after 1988. I don't have enough space on my graph to do that because, let's see, how far can we get? 18, 20, 22, 24. So I only got to 24. You would have to keep going to 30 and then go up from that spot. I'm guessing it's going to be like 500. No, I bet it's going to be even more than that. But in order to predict, you would have to extend your graph on both sides. What a pain in the butt, right? Don't worry, today I'm going to show you a different way to predict where you don't have to extend your graph. All right, so let's continue. When you're making predictions, there's this thing called interpolation or extrapolation. Interpolation is good. We like that. You're making a prediction inside the range of the data. So for example, in lemonade sales, if you make a prediction somewhere between 60 degrees Fahrenheit and 110 degrees Fahrenheit for how much money you're going to sell, we could predict at 90, we could predict at 100, exactly how much lemonade we're going to sell. That's going to be interpolation. Extrapolation is a prediction outside the range of the data. So if I were to extend my graph, so if I were to go way down to 30 degrees, that's extrapolation. It's outside the range of the data. All right, so let's go ahead and make a prediction. If I extend the salaries graph and we go up to, let's say, 30, and I predict that at 30 years of formal education, I'm going to make $200,000. Would that be interpolation or extrapolation? Extrapolation is correct. All right. Last example here, kiddos. This is what I was just now telling you about. In order to make a prediction without making your graph bigger, you would have to write an equation for the line of best fit. So the first thing I'm going to do is I'm going to draw a line of best fit. I'm using the salaries one, about the years of formal education and the annual salary that you make. You notice it's a positive, strong correlation. The more education you get, the more money you're going to make. And that looks like a pretty good line without a ruler. Now, to write an equation for the line of best fit, I need to use everything that you just learned and were tested on. So if I were you, I would use point slope form. That's y minus y1 equals m x minus x1. So in order to fill in this equation, we need to find the slope. How do you find the slope? Well, we got to find a couple points, not on our graph, but on the line. So since my line is not super straight, this might not be perfect, but we'll do our best. Alright, so I've got a point right here. And it looks like I might have some more points as we're going down on this line here. Yeah, I did okay with my line of best fit. Alright, so I'm going to pick 2 points. I'm just going to write their ordered pairs. I've got 20, 125, and I've got 18, 100. Any points will work as long as they are on your line. So the first thing I want to do is find my slope. I've got 125 minus 100 over 20 minus 18. That means my slope is every $25,000 I want to earn, I need 2 more years of education. And I'm not going to be able to simplify that any further. So then I'm going to pick 1 point to plug into my equation. I'm going to use this one because they're prettier numbers. So we got y minus, actually let's do a different color so we can separate this here. We've got y minus 125 equals 25 over 2 x minus 20. Now we just need to make it pretty. Distribute, make it a y equals mx plus b, and we'll have our equation. Alright, so there we have it. Our final equation is y equals 25 over 2x minus 125. Now many of you might be thinking, why didn't we just start with y equals mx plus b? Well, it's because we didn't know the y-intercept. See this little jump heartbeat here? It didn't start at 0. So 25 right here is not my y-intercept. This graph actually continues a long ways, and the y-intercept is negative 125. So everything that we've been learning is valuable, and it is able to be used in the real world. Alright, so I'd like you to do some practice with this. Your homework is page 250, numbers 3 through 8. You're going to turn this in by the end of class, no matter if you have finished it or not. I will not accept anything late. So what you turn in is proof that you were working hard in class today. So you got number 3 where you have to make a scatter plot. 4, 5, 6, 7 are just correlation. And then number 8, you're going to have to use the scatter plot. Okay, so you only have to make 1 scatter plot. Shouldn't be a lot. You should be able to finish this. Have a great day, and I'll see you guys on Monday.